Hello, welcome to this lecture on modeling, analysis and estimation of three-phase unbalanced power network. We have been talking about the process of solution of the equations. So, what we did in the last class is that we first talked about the unknown as well as the known vectors for solving the three-phase power flow, and then we have done a little bit of recapitulation for the single phase power flow method, and there we have said that how this basically known vectors as well as the unknown vectors, they are related with each other by means of the Jacobian submatrices, and then using that concept we have straight away written down the relationship the between the mismatch vector for the three phase load flow as well as the unknown vector for three phase load flow in terms of the Jacobian matrix. And we have said that because there are four sub vectors in the overall mismatch vector, and also as there are four sub vectors in the overall unknown vector, so then therefore there would be 16 Jacobian submatrices in the overall Jacobian matrix, and that is what we have said. And then we have also written them like this. So, we have got total J1, J2, J3, J4 up to J16. So, now our task is to look at this all these entries in more close detail. So, to do that, let us first let us again write it in a fresh page, because we have to write it in a more detail, we will need more space actually. So, just let us write it in a fresh page. So, what I have got is that del P del Q. So, del P del Q del P gen and del V specified that would be and we have written as del theta del V del theta, these are all vectors del theta del V del theta internal del V internal, and then J1, J2, J3, J4, J5, J6, J7, J8, J9, J10, J11, J12, 13, 14, 15, 16. Now, let us look at them. First, let us look at their dimension. Now, as we said that P vector has got a dimension of 3n, 3n. So, P vector has got a dimension, let us write it here, otherwise it will be difficult. So, this is 3n cross 1, this is also 3n cross 1, and why these are 3n cross 1 and etc. we have already explained. So, this is m minus 1 cross 1, this is m cross 1, theta we said we are saying that we are taking we have already explained that this has got a dimension of 3n minus 1 cross 1. Why it is 3n minus 1? Because I mean basically what are these theta angles? Theta angles are nothing but the angles of the original n buses in the system corresponding to every phase except the phase A angle corresponding to bus 1, because we are taking that particular bus angle as a convention to be the reference angle. So, then therefore, we are taking that particular bus angle to be 0. So, as a result that particular bus angle need not be solved. So, my total number of unknown quantities become 3n minus 1 cross 1. V of course 3n cross 1, because I have to, what is V and delta V? V is again the voltage magnitudes at all the original n buses corresponding to each phase. Theta internal are all theta internals, they are m cross 1, and V internal is also m cross 1, right. So, why these are these dimensions that we have already explained. So, because we have got these dimensions, so then now we can straight away write down that what would be the dimensions of J1. What is J1? J1 is 3n cross 3n minus 1. So, this is J1. What is J2? Delta P is 3n, V is 3n. So, then therefore, it would be 3n cross 3n. What is J3? J3 connects delta P with delta theta int. This is 3n, this is m. So, this is 3n cross m. And J4 also connects delta P with delta V internal. This is 3n, this is m. So, this is 3n cross m, right. Okay. What is delta Q? Delta Q is connecting, I mean what is now the dimension of J5? J5 is connecting delta Q with delta theta, and delta Q is 3n, this is 3n minus 1. So, J5 will have the same dimension as that of J1. J6 connects delta Q with delta V, and this is 3n, this is 3n. So, then therefore, J6 will also have the same dimension as that of J2. J7 connects delta Q with delta theta int. Delta Q has got the dimension 3n, delta theta int is m. So, it will 3n cross m. So, it will also be same dimension as that of J3. Similarly, J8 also would also have the same dimension as that of J4. What about J9? J9 connects delta Pgen with delta theta. Now, delta Pgen is m minus 1, and this is 3n minus 1. So, J9 I would say that J9 is m minus 1 cross 3n minus 1. J10 would be, J10 connects delta Pgen with delta V, it is m minus 1 into 3n. So, it is m minus 1 cross 3n. J11 connects delta Pgen with delta theta int, it is m minus 1, it is m. So, it is m minus 1 cross m, and J12 is also same thing, it is also m minus 1 cross m, correct. Now, what happens to J13? J13 it would be m cross 3n minus 1. What about J14? J14 also M cross 3n. What about J15? J15 is M cross M, because it is M, this is also M, M cross M. And what about 16? J16, it is also M, this is also M, so J16 is also M cross M. So these are the dimensions of the various Jacobian submatrices. Now what is J1, J2, J3, J4 definition? So the definitions are also straightforward, although we have to elaborate them, but first let us write down the definitions. So the general definitions first let us write down, and of course we will elaborate them in due course of time. So the definitions here let us write down. From here, J1 is basically del p by del theta, but as we have done for the balanced load flow, that we have also looked at the individual element of this matrix. So here also we will look down at the individual element. So that we will do, but first let us write down that what are the definitions. J2 would be del p by del v, J3 would be del p by del theta int, J4 would be del p by del v internal, J5 would be del q by del theta, J6 del q by del v, J7 del q by del theta int, J8 would be del q by del v int, J9 would be del p gen by del theta, then J10 would be del p gen by del v, J11 would be del p gen by del theta int, J12 del p gen by del v int, J13 del v specified by del theta, J14 del v specified by del v, J15 del v specified del theta int, J16 del So these are the definitions. These are the general definitions. This is in the same line as we have done for the balanced load flow. Now you see J1 is del P del theta and del P del theta, and this is an matrix. It is 3n cross 3n minus 1 matrix. So let us look that what would be this matrix. Now to do that, let us first to do that, let us first. So J1 is del P del theta. Now let us recall that what is P vector and what is theta vector. Let us recall, otherwise I mean without this recollection we will not be able to write down this elements of J1. So what is P vector? Vector P. It is basically a 3n cross 1 vector. So what is this vector? It is basically a 3n cross 1 vector which essentially have the specified power at each original bus corresponding to each phase. So then therefore if I have got n bus system and m generator etc etc, so then therefore P would be P1A, P1B, P1C, then P2A, and then dot 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 PNA, PNB, PNC, right? And what is P1A, P, and basically this notation of PIP we have already defined earlier several times, so we are not really again repeating it. So it is T, right? So we are not really again repeating it. So PIP again, as we can see, I varies from 1 to n and P is ABC, right? And what does mean PIP denotes that we have already seen, so we are not different. What is theta? Theta vector is essentially theta 1b, theta 1c, then theta 2a, and then dot 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 theta NA, theta NB, theta NC transpose. Correct? As you can see here, it has got all the voltage angles at all the buses corresponding to each phase for all n original buses except theta 1a, because as theta 1a is taken to be 0. Theta 1a is taken to be 0, that is the reference bus. So this is the reference angle. So as a result we really need not solve it. So then therefore unknown angle vectors will contain these quantities. And because of this we have already seen that this is 3n cross 1 and this is 3n minus cross 1. There are 3n but only one is missing, so 3n minus cross 1. So now with this, so now what will be J1? So it will be nothing but partial derivative of essentially the vector p with respect to the vector theta. So following the same, it will be del p1a by del theta 1b, del p1a by del theta 1c, and then del p1a by del theta 2a, right, dot 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 del p1a by say del theta na, del p1a by del theta nb, del P1A by del theta n c, right. So, this is the first row. What would be the second row? Second row would be del P1B by del theta 1B, right. Then del P1B by del theta 1C, and then dot dot dot, and of course the next term would be del P1B by del theta 2A, and so on and so forth, then dot dot dot. Here it will be del P1A by del theta NA. So, here it would be say del P1B by del theta NB del P1B by del theta NC, right. So, this is the second row. What would be third row? Third row would be del P1C by del theta 1B, del P1C by del theta 1C, and then dot dot dot, del P1C by del theta NB, del P1C by del theta NC. That will be the third row. Fourth row would be essentially the partial derivative of P2A with respect to all these angles theta 1B, theta 1C, theta 2A, and theta NC. So, similarly, so then if we go on like this, so then last but one row would be del PNB by del theta 1B del PNB by del theta 1B, then del PNB by del theta 1C, then dot 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 dot, this is also dot 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 dot, etc etc, then dot dot dot. This would be del PNB by del theta NB del PNB by del theta NC, right. This is the last but one row. What is the last row? Last row is PNC. So, last row is del PNC by del theta 1B del PNC by del theta 1C, right, del PNC by del theta 1B del PNC by, because this is the last one, and then similarly we keep on going del PNC by del theta 1C, del theta NB del PNC by del theta NC. So, these are the elements, individual elements. So, what is the dimension? There are n power P1A, P1B, P1C, and there are, and in the column we are talking about the angle. So, it would be, as we have said, it would be 3n cross 3n minus 1, correct. Now, the point is, so then therefore, of course, it is basically a rectangular matrix. So, it is a rectangular matrix. So, it is not a square matrix, of course not for any value of n. This is a rectangular matrix, but then the general term is del PIP by del theta JL, right. Any general term is del PIB by del theta JL. I varies from, now I and J I and j, they varies from 1 to n, and p also varies from a, b, c, l also varies from a, b, c, except theta 1a, right? Theta 1a doesn't exist. So then therefore theta 1a doesn't exist, correct? Theta 1 is a known quantity, 0 quantity. So now obviously we have to now find out the uh, general expressions of this del pip by del theta jl, where I can take any value, where this index I can take any value 1 to n, and this particular superscript p can take any value a, b, c. Similarly, j can take any value 1 to n, and l can take any value a, b, c. And then of course, once we have got these general expressions, then we would be able to find out this particular matrix, right? So this will take time, so we will do it in the next class. Thank you.